Okay, so what I'm about to explain to you is an easy way to remember all the trig values on the unit circle, which are just sine and cosine values. Okay, so every time I put a set of parentheses, what that means is inside of this set there will be two numbers in here, and these numbers represent the cosine and the sine of that angle that we're going to talk about. Okay, this is your standard circle. Every circle has 360 degrees in it. It means if I start here at this dot and I go all the way around this circle, I'll be back to 360 degrees. And we're also going to call this 0 degrees. So this will be 0 degrees and 360 degrees. So if I start here at 0 and I go halfway around the circle, I'm at 180 degrees. I start here and go halfway to there, halfway to 180, this is going to be 90 degrees. What that means is this right here is a 90-degree angle. So that's pretty easy to see. Okay, and then down here, if I scroll down here will be 0, 90, 180, all the way here will be 270 degrees. 90 more degrees will get me back to 360. Okay, so for this 90-degree angle, it has a pair of numbers, and that's going to be the cosine of 90 and the sine of 90. And we know the cosine of 90 is 0, and the sine of 90 is 1. Over here at 0 degrees, we know the sine of 0 degrees is 0, so that will go here, and the cosine of 0 degrees is 1. Now over here, we know the cosine of 180 is -1, and the sine of 180 is 0. And down here, at 270, we'll notice that this pair makes 0, -1. Now these don't really have to do with the coordinate plane, but you can easily see that if this were an ordered pair, this would be at 1, 0 if this was one unit. And this would be 0, 1 up here at 90. This would be -1, 0 at this ordered pair. And down here at this ordered pair, this would be 0, -1. Now, it's not really the reason why these four are like that, but that's an easy way to remember it. Okay, if you split these up into 45-degree angles, which are called quadrantal angles, as if you were maybe cutting a pizza or a pie, you kind of start to see this thing take shape. So right here, 45 degrees would be right here. 45 more degrees would be 90. 45 more degrees would be 135 degrees, then 180. And continuing on around, you can see it would flesh out like this: 225, 270, 315. And then 45 gets me back to 360. Okay, so I have 45 degrees, 45 degrees. Each of these represent 45 degrees. Now the 45-degree increments that are these four numbers right here, these four angles, 45, 135, 225, 315, they all have the same numbers in these slots, so that makes it easy. Square root of 2 over 2, square root of 2 over 2, so that's easy to remember. Now the thing is, everything in this quadrant has the same sign for cosine and sine, same SIGN anyway. Everything over here is the same, everything in here is the same, and everything down here in quadrant 4 is the same. And the signs kind of go along with that coordinate plane you've always learned. Up here in quadrant 1, you've always known that the ordered pair was positive, positive. So these in this quadrant 1 is positive and positive. Both of these are positive. Over here in quadrant 2, this is negative, positive. So we'll notice that our ordered pairs look like that. Now that's just a handy way to remember it. It's not necessarily that that's why that's like that, but it does have something to do with it that I'm not going to talk about. Down here, all of these are negative and negative. So I'll just put this right here so we remember, and over here in quadrant 4 this is positive and negative. So I'll put this down here for us to remember, which means that this one is negative. So what this means is the cosine of 45 degrees, so we look at this number right here, and that's the square root of 2 over 2. The sine of 45 degrees is this number right here, also square root of 2 over 2. Cosine of 135 is negative square root of 2 over 2. Notice the cosines are all negative in the second quadrant. So that's where you get all your 90s and your 45s. Okay, if you take this circle again and you split it up into thirds, coming up here like we just split this into fourths, now let's split this, each of these quadrants into thirds, which would mean I'm going to take 180 and divide it into sixths. I want 6 pieces in here. It means each piece needs to be 30 degrees, which is going to be about right there. These may not be perfect, but get the hint. Okay, each of these lines now represents 30 degrees. I'm going to make these in a different color. I guess I'll use green this time. So if I start at 0 and come up to here, this is 30, and then this next one will be 60, and we notice that we hit 90, but we already got that one, so I'm going to skip that. 120, over here would be 150, 180 we already got. 210, 240, 270 we already did, 300, 330, and now we're back to 360. Okay, so each of these green numbers will get its own set of parentheses. And these numbers are, the cosine of 30 is square root of 3 over 2. The sine of 30 is 1/2. And so we can see that these are both going to be positive because both the signs are positive in the first quadrant. And once you get this 1 down right here, you can just use reference angles to fill in all the other green numbers. Okay, reference angle is the angle it makes with the x-axis. So I'm looking at this angle right here, which is 30 degrees. It's going to be the same as this one over here. So this pair is the same as this pair, except for the sign, the SIGN. So this one's going to be negative. Let me erase that and write that neater. Up here, these two are the same numbers as these, only switched. And since 60 degrees reference angle is right here, that means this also has a reference angle of 60, so these are 1/2 and square root of 3 over 2. And we can see that the SIGN will be negative. Cosine is negative in the second quadrant. Coming down here and looking at these reference angles, this 330 has the same reference angle as this small one right here, so that would be these two numbers. And we notice that these two numbers are positive because this is in quadrant 1, but in quadrant 4, the sign of sine is negative. And the same with this one, it'll be these two numbers over here. Except this time the SIGNs of both of these are negative. For 240 and 300, you'll notice those have the bigger reference angle, the 60-degree reference angle. So that's going to be these numbers up here, 1/2 square root of 3 over 2. Paying attention to our SIGNs, See that it fills out like that. And that's it. That's the unit circle explained with degree measures. Now, if you want to do radian measures, which means I'm going to erase all of these degrees and talk about what this would look like in radian, the values for sine and cosine don't change. The only thing I'm doing is changing the way that I'm talking about how we're going to describe each angle. Now, without getting into why it is the case that this is 2 pi, we'll just start with the fact that it's 0 degrees for sure. Except we're going to now call this radian, which talks about the length of this arc. This is 0 arc length, or 0 radian. It's nothing from here to here. But also, all the way around here, the circumference of a circle with a radius of 1 is 2 pi r, so 2 times pi times 1 is 2 pi. So this is 0 radians if you don't go anywhere, and it's 2 pi for a length if you go all the way around and come back to here. That means that if it's 2 pi all the way around, only halfway around that is half of 2 pi, which is just pi. So we'll call 180 degrees pi radians. Coming up to here where it used to be 90 degrees, well, that's halfway to pi, or half of pi. So we're going to call that half of pi, or pi over 2. Now this one was 45 degrees. This was halfway to 90. So what's half of a half? Or in other words, a fourth of the way all the way to here. So this would be 1/4 of pi, or 1 pi over 4. And then 2 pi over 4 would reduce to pi over 2. 3/4 pi, we'll call that 3 pi over 4. And then 4/4 pi, it just reduces to pi. Down here, this would be 5 pi over 4. And then 6 pi over 4 reduces to 3 pi over 2. Then 7 pi over 4 is here, and 8 pi over 4, we're back to 2 pi. So these numbers don't change out here. We're only changing the way we describe how to get to those numbers for sine and cosine. Now what we're going to do is split this up to 30-degree increments, which means that I split this top half up into 6 equal pieces. So I'm going to do that again. And I'm going to say that 1/6 of pi is right here. So this would be 1/6 pi, or pi over 6. And this one was 2/6 of pi, which reduces to pi over 3. Add another 30 degrees right here. Down here would be 30 degrees. Up here would be another pi over 6 radians. So I go 2 pi over 6 plus 3 pi over 6. Sorry, 2 pi over 6 plus 1 pi over 6 would give me 3 pi's over 6, which is pi over 2. 4 pi over 6 reduces to 2 pi over 3. 5 pi over 6. 6 pi over 6. 7 pi over 6. 8 pi over 6. 9 pi over 6. 10 pi over 6. 11 pi over 6. And 12 pi over 6 is back to 2 pi. So that's it. The radian measure doesn't really affect a whole lot. It's just a different way to describe those same angles, except it's talking about the length of this arc and not this angle measure down here.